All right, what's up, AP Stats, Chapter 6, FRQs, here we go. First thing is, says, what is probability the person selected will be never and a woman. So this is going back to the first part of Unit 4, probability, and is the overlap, and would look like that. So we could do never and woman, like that. Whereas part 2 here is the word or, so that would be a union, something like that. This one has a formula. You can always use the formula for that in your formula packet. Because we have a chart, we're just looking at the overlap. So where does the never overlap the woman category? And that's just right there. Whereas the or is all of this added together. It's either never or it's woman or both. Okay, so there's that. And then part 3 is a given. So you have to use the given formula to get 0.12. Or you could say, all right, if they're a woman, it's you're just looking at this right here. So out of 53%, how many were never? 0.0564. That's another way of doing that. But in general, you have the formula for that in your formula packet. People tend to forget that. For part B, is it independent? So what I did was I looked at the probability of never. And it's just 0.12, it's right there. And then I compared, how does never compare to never given you're a woman? And it turns out they're equal. 0.12 is equal to 0.12. So therefore, being a woman did not change the probability of having never taken your meds. So they're independent. Gender did not affect the probability. So therefore, independent. And lastly, C, this sets up a binomial. You can go through bins and check it out. But we're just looking at in 5 trials with a 0.54% chance of success. I want to accumulate 0 to 4 out of 5 people taking their medication as prescribed. All right, so those are my short answers. If this was the real test, I would write a little sentence about that. I would say the probability that the person selected will be someone whose response is never and who is a woman is 0.0636. I would literally write the whole question out again to give it context. You can't just leave an answer blank. In fact, if you saw it on Canvas, these are the solutions. At the minimum, you got to write a little bit of context like that. For part 1, at a minimum, you should show a little bit of work. In general, this was the real test. You definitely want to show your calculation. All right, that's the OR formula that's in your formula packet, and that's the given formula that's in your formula packet. So show the calculation. Part B, look at the answer. They give context. Write a little context. They don't just put the answer down, they write a little context. And then part C, this is a little overkill. You don't have to do this. This is the 5 choose 4, 5 choose 5. Oh, did I do this wrong? Wait a second. Hold on. We want to know the probability of at least 4. Ooh, I did 0 to 4. I need to change this. This should be 4 to 5, shouldn't it? I want the other side of 4. I want the top side of 4. And I wrote that down wrong. But that is the right answer. My mistake. All right, number 5. Check it out. It does say approximately normal. Whenever I see the word approximately normal, or the phrase approximately normal, I'm gonna make a little bell-shaped curve. Helps my mind to get into the problem and understand what's happening. Okay, how many months from the date of purchase is it expected that 25% of the batteries will no longer work? So I drew my thing and I put a little mark here at where I think 25% would be. All right, and it's right around, I don't know, it's right around there. I don't know where this is exactly, but I'm pretty sure it's more than 1 standard deviation. 1 standard deviation would be 16%. using the empirical rule, and 34%, and then 16%. So I knew 25% had to be on the right side of 22. I didn't know what exactly it had to be. I knew it was probably close to 22, but I don't know how close it was. Anyway, this is an inverse norm problem. We have the area on the left of our mark. We want to find that mark, so inverse norm, and it ends up being 24.6 months. And for B, this time we want to know the area to the left of 24. 24 is the boundary for if it's replaced at no cost to the customer if the battery no longer works within the 24 months. So that's so what percent do fail at the 24-month mark? So this is a norm CDF problem. I want to know the probability. I want to know the area under the curve. And so lower bound of 0, and you could keep negative infinity if you plug that in, that's fine too. 0, it just has to be something really small in relationship. And then 30 and 8, and I get my answer right there. And of course, I wouldn't just leave these as the answers. I would give context to the answers. For part C, you either lose $150 if you are below 24 months, or you gain $50. The company gains $50 if you're above 24 months. So we use the probability from part B. So the probability of losing 150 is equivalent to the probability of being less than 24 months. So that's that. And then that has to be the complement of that. They either lose it or they don't. So these had to add up to 1. And then the expected value is that times that plus that times that times that plus that times that, 468. So that is that's just good business on the part of this company, because they're providing a service. Some people like the peace of mind of having that warranty. And when you buy a warranty, you know that you're probably not going to use it, all right? But if you do have to use it, you are going to really love that you purchased that warranty. And for every warranty purchase, the company still makes almost $5. All right, so they are going to make money in the long run with each warranty. That's a good question. Number 3, we got a full carton of eggs. Sets up a normal distribution. 850 will be just slightly to the right of normal, of average, of 840. So I drew a little line there, and I'm going to find the area using norm CDF from 850 to, I put in something really large, and I got that. So it's about 10%. Diagram, not the scale. All right, that should be a little bit further to the right if it truly is 10%. For part B, this one was pretty tricky. All right, we're setting up, they keep saying independence. Those are like some buzzwords where I'm like, okay, they're gonna combine things. We're combining 12 eggs and we're combining 1 egg carton. That's the total weight. Okay, so 12 eggs and 1 egg carton. Let X be the weight of a single randomly selected egg. So I took the total weight of the carton, the total weight of the eggs and the carton, and I took away the weight of the carton. Okay, so taking away the weight of the carton now gives us just the weight of the eggs. And then I divided it by 12 because there are 12 eggs, and you get this, 68.33 grams per egg. Okay, again, I wouldn't just leave that as my answer. I'd write some context, explain what that answer actually is. That's the average weight of a particular egg. And then the standard deviation, this one got tricky. So I said T was the total, so that's carton and eggs. C is just the carton or container, and E, that says E. E is an egg. All right, so the total standard deviation, you can't just add the standard deviations, right? We got 12 eggs and we've got 1 carton. So you can't add the standard I can't do that plus 12 of those standard deviation. I've got to do the variance. I got to take the variance of the carton plus 12 egg variances, and then square root it. So that's the equation right there that would tally up or total up the carton plus the 12 eggs. All right, so now I plug in. I knew what that was from above. I know what that is from above. I got 12 eggs. I'm going to find the variance. Now, algebra. Let's take a look here. If we're doing this algebraically, if I'm solving for that, I'm gonna plug in 7.9 in my calculator, and now I gotta work backwards. So I gotta get rid of the square root, which means, what's the opposite of square rooting? Squared. Okay, now I gotta subtract this away. So I'm gonna subtract 1.7 squared. So I'm just working through the algebra, and now I gotta divide the 12. All right, and this is now equivalent to the variance. I've just found the variance. And then how do you get standard deviation from variance? You square root it. Oop, where is that at? All right, so there's where that comes from. That is the standard deviation of one egg. All right, next one. Got a game spinner, and it takes $2, and this is the net contribution. So if you spun a 0, you contributed $2 to the game, to the charity or whatever game this is. If you spin a 1, you contributed $1. You paid $2 and you won $1, so the net takeaway would be $1 for the person running the game. And then if you won $10, the net takeaway would be negative $8. So is this a good game or not? It depends. So if you look at the probabilities, the expected value is just 2 times that plus that times that plus that times that, right there. 70 cents per play. In the long run, the game is going to win. You are not going to win. In the long run, you are going to lose 70 cents per game, and the game will win 70 cents per game. Okay, but you might get lucky on your first or second try, and you might come out ahead. So it's just hard to say, but in the long run, you would lose, on average, 70 cents per game. So you win 70 cents per game. So see, the charity wants to know when they can get $500. Okay, well, if you win 70 cents per game, 70 cents per game equals $500. You just got to divide by 70 cents. And this is interesting because when you divide, you get 714 point blah, blah, blah. And now if you play 714, you're not quite going to have $500. So in this case, you do actually want to round up to 715. 715 guarantees you're over 715, you're over 500. 714, you're under 500. So we said 715. And then they end it with a normal distribution. They give you the mean and standard deviation. So I set up my normal distribution, and I put 500 on here. I knew 500 was less than 700, so I just put 500 to the left over here. And I'm looking for this area right here. I did norm CDF, I got my answer. All right, now if you go and look at the solutions that I posted, those are the official solutions. Those are good, and they show all the context. They show how you should write your answers, but they do it the long way. They use z-scores. This is a much more streamlined way. It's good to know how to do both. So if you really want to get into this stuff, you're going to need to know how to do it the long way. And I would recommend going and looking at these solutions that I posted. All right, just go to the handout that I posted on Canvas and check out the solutions. They're at the end of that. All right, that's all I have to say about that. Okay, a little bonus content for the people that are still hanging around. Take a look at, got your test here. Here it is. Woo! 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 There's your test. Start off with some true or false. There's some words like continuous versus discrete. There's some words like combination, combining variables. You have to know how to combine. There's some words like standard normal. What is a standard normal? If you don't know what a standard normal is, go Google it. There's words like a normal probability plot. There's words like 10% rule. Ooh, the 10% rule. Remember that one? 10% rule has to do with independent events. All right, we have a discrete probability distribution. We have a density curve. We have a normal distribution problem, norm CDF or inverse norm. We've got a binomial happening. Doesn't say binomial, you have to be able to spot it. There's a binomial. There's a question about the empirical rule. 68%, 95%, 99.7%. Okay, 68% is 1 standard deviation from the mean, 95% is 2, and 99.7 is 3 standard deviations from the mean. There's a question, another normal distribution. Is it inverse? Is it norm CDF? You decide. There's a, remember the SAT, ACT question about Bob and Lou and who did better? There's one of those on there where we have to compare the z-scores. There is it says which of the following is not true about distributions. There's combining two distributions. Remember, you cannot simply add these standard deviations. And even if doesn't matter if you're adding two distributions or if you're subtracting two distributions, you always will increase in variability after that, okay? Doesn't matter if you're adding or subtracting two distributions, you will always increase in variability. All right, let's see here. Expected value, standard deviation. Yep. Ooh, there's a good combining problem about some a mixtape of songs. You're combining things together. That's a good one. Ooh, the word until shows up in a multiple choice. That's a tough one. That's a tough one. Good luck. Number 21 and 22. It's a discrete random variable. You have to find the mean and the standard deviation. I'd recommend using your calculator. You don't want to do that's a very long formula. If you look in your formula packet, and there's lots of room for error, you got to know how to find that in your calculator, mean and standard deviation. And now we're finally on to the free response questions. There's a question about a density curve, and you might want to know the area of a trapezoid going into that. Area of a trapezoid. Go look in your notes. We did one very similar. And then there's a question about free throws. And the word until shows up again. Okay. Until. And yeah, that's that. Know the two rules. There were two rules. There was a rule about when you can assume independence, the 10% rule. And there was a rule about when you can use a normal in the place of a binomial, even though the normal is for continuous data and a binomial is for discrete data. So that was the last lesson. So go take a look at those, know those two rules. And that's all I have to say. Good luck.